Hello students, this video is going to cover lesson 1A in unit 5. Just a reminder that we're going to skip unit 4, which was on rational expressions, because we're going to focus on quadratic functions and solving quadratic equations. So this is your page 59, I believe, in your note package if you're using the notes to follow along. So I'm just going to share that, and here we go. So pre-calculus, unit 5, this is chapter 3 in your textbook. Also a reminder, I am going to start assigning practice questions out of your textbook. So if you don't have yours or don't have access to yours yet, it is available online. I have provided the link at the beginning of the section, the math section on my website. Right, so we're going to start with recall linear functions. So at the end of Math 10, you learned about linear functions and linear lines, and you graphed them, and you solved them, and you learned 3 different formats to discuss them. You learned slope-intercept form, you learned slope-point form, and you learned general form. So looking at slope-intercept form, this was the y equals mx plus b format. Does that ring a bell? I hope it does. Where m is the slope and b is the y-intercept. And your linear functions had a constant slope, so you could calculate by finding any 2 points and find the rate of change between those 2 points to find that slope. So we're going to be talking about quadratic functions, and quadratic functions have a slightly different format. They have, here's an example of one, and I'm going to just kind of copy it down and make sure I do the same one. 5x squared minus 13x plus 2, and that should look really familiar. That's what we just spent the last little review section working on. That is a trinomial. And when you plot a trinomial out, it ends up looking like a curve, either a mountain curve or a valley curve. And we call those curved lines parabolas. And we're going to talk a lot more about those later on. But right now, I'm just going to tell you that this is what we call general form. Now, your textbook also calls this standard form. But I'm going to get to that in a second, this whole naming convention thing, standard. Okay. There is another format that we're going to talk about as well, and that is y equals 1/3 x minus 2 squared plus 7. It actually doesn't really matter if I use the same ones that are in my notes, but I'm a perfectionist like that. So this format is called vertex form. Now, when I went through school and university, we called vertex form standard form, and Mr. Lautet calls vertex form standard form, and a lot of other people call vertex form standard form. So even though the textbook calls general form standard form, I disagree with the textbook on that name, and so I'm just going to try to stay away from the word standard form to begin with, because there seems to be a little bit of contention which one of these forms, general or vertex, is standard form. General is general form and vertex form is vertex form. There's no switching those two around. So that's why I'm going to stick with using those words, but just be aware that the textbook calls general form standard form, but then you might have other people, teachers, professors, calling vertex form standard form. All right, so we're going to just investigate what the most simplest parabola or quadratic looks like when it is graphed. So y equals x squared is the most basic thing. It's just got, there's nothing in front of that x squared, there's nothing being added or subtracted to that x squared, it's just y equals x squared. So the first thing we're going to do when we investigate things, we're going to plug in values into, or for x, and find out what would y equal, because it doesn't involve any solving, it just involves following BEDMAS. So I'm going to put some values, -3, -2, -1, 0, 1, 2, and 3. So for example, if I want to know what y equals when x is -3, I would substitute -3 in for x. Remembering that when we substitute inside brackets. So it's not just the 3 that's being squared, it's the -3 that's being squared. So when x is -3, y is going to equal 9. Okay. I want you to pause the video here and go through the rest of those x values to find out what y would equal if x is -2, if it's -1, if it's 0, 1, 2, and 3. So hopefully you've done that and you're coming back. That's 4, 1, 0, 1, 4, and 9. And hopefully you see that there's a little bit of a similarity. So, and that's because when you square something, that doesn't matter if it's negative, when two negatives are squared, it also becomes positive. So if we were to plot this out, when x is 0, y is 0, actually I'll start at the very beginning. I'll start with this one right here, okay? So when x is -3, so you count back 3, y is going to be 9, and then you count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when x is 3, y is 9. When x is -2, 1, 2, y is 4. So count up 1, 2, 3, 4. And when x is -1, so here's -1, y is 1. So it's up here, okay? And then when x is 0, y is 0 right here. And when y is 1, +1, x, when x is 1, y is +1. When x is +2, y is +4. I'm sorry, I'm really flustered right now. I'm just gonna go back and delete that. So when x is +1, y is +1. When x is +2, y is +4. 1, 2, 3, 4. And when x is +3, y is +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if you were to join those dots or sketch this, it would look like this. Okay. So it's kind of like a little cup. We call this a parabola. Parabolas are for quadratics. Okay, we call them quadratics, and it involves trinomials. So it's another, technically anything with 3 different terms, unlike terms, is a trinomial, but the specific ax squared plus bx plus c trinomial is specifically a quadratic trinomial, which forms a parabola. All right, so we're going to talk a little bit about domain and range, and then we're going to go through a bunch of examples that are kind of going to be, you try them and then just see, check the video to see if you got them right. Okay, so for domain and range, domain has to do with how many values along the x-axis are possible to find some value. Like if I picked -10, if I go up high enough or low enough, will I find a point on that parabola? And the answer is yes. All parabolas, unless there's some other sort of thing stated, have a domain of all real numbers. So you could keep going this way on into negative infinity, and if you went up, eventually this parabola would go up high enough, it would go out enough to the left, the negative direction, that you would find a point on that parabola. Okay, so we say the domain is x can be any real number. Okay, so little math 10 review as well. This symbol means can be any. And the R technically has a double stick. That is can be any. The R stands for real number. I stands for integer, IR stands for irregular, N stands for natural, W stands for whole number. Oh my gosh, unit 1 review right there, guys. Okay, range So domain has to do with the x values, the possible x values. Range has to do with the possible y values. So it's the range of y values possible, right? So we're going to look at what values of y are possible. So if you look at this graph, you can find any value of y. You could go up and up and up to positive infinity on the y-axis, and you could go either left or right, and eventually, because this is going like this, you will find some point on that parabola, no problem. But if you go in the negative direction, if you go left or right, are you going to run into that little green line that we did to draw or sketch the parabola? The answer is no. So for this basic parabola, the range is y has to be positive, and it can also be 0. So how we say that in math speech is y has to be greater than or equal to 0. Now you might see this represented in slightly different ways. You might see y bracket for the domain. It would be y has to be greater than or equal to 0 and less than or equal to positive infinity. You might see it written that way, and you might see it written like this, where it has to be greater than or equal to 0 and going up to positive infinity. All right, so the last one there with the weird thing, I'm not going to focus on at all. That was something I was going to do at the very end for inequalities. We're not going to see things like that, but I just wanted you to know, especially for my international students who might have already seen this, that that is a totally acceptable way of stating domain and range. If the textbook shows it as an example, you're not wrong for writing it this way, or for writing it this way. I will accept all three. Really, I just want you to know that there's no values on the parabola for y below 0. That's the important part that you get out of this. All right, so the other two things we're going to cover is what is the equation for the axis of symmetry. Okay, so axis of symmetry, I'm just going to... So if you're in biology and you've taken life sciences, you might have learned already about symmetry, specifically talking about bilateral symmetry or radial symmetry. So we as humans have bilateral symmetry, meaning that if you cut us down the middle, our one side relatively looks like our left side, you can fold us in half. Where starfishes have like a 5-point radial symmetry because it's around in a circle. There are symmetries in a circle. Parabolas are like humans. They have bilateral symmetry, meaning if you cut it down the middle and directly through the exact middle, the left side and the right side are going to look the same. So here I'm going to sketch the axis of symmetry. Okay, so the axis of symmetry goes right down the middle, and any point here is going to have an equal but opposite point over here. And the distance between these 2 points, like if I compare these 2 points, the distance from this point, which I'm circling in red, to the y-axis is exactly the same as equidistance from this point also to the y-axis. Okay, they're the same distance apart because it's right down the middle. Okay? So in this case, the equation is going to be x equals 0. So no matter what you have for y, y is 5, x is 0. Okay, so y is 1, x is 0. Y is 3, x is 0. Y is up here, x is 0. So the equation for the axis of symmetry is y equals, sorry, not y, x equals 0. It's really making me show you my mistake there. I wouldn't delete it. X equals 0. The axis of symmetry for parabolas is always going to be x equaling to something. 1 second. Somehow got unplugged and my battery is low. All right. So the coordinates of the vertex. So going over some basic parabola jargon here, the vertex is either the lowest point possible on a parabola or the highest point possible on a parabola. It will never be both. It'll either be a valley, right, with a very bottommost point or a minimum point, or it will be this hill-like shape where it has an uppermost point, a peak. So right here is the lowest point of this parabola, okay? This is the vertex. And that vertex happens when x is 0 and y is 0. Which way does this open? So which way does this parabola open? There's opening up and there's opening down. This one opens up. So I lost my, don't know where my scroll bar decided to move on me. Okay, so it's getting quite messy in here, but the parabola is opening upwards. It's opening up. Okay, this parabola only intersects the x-axis in one place, and that's at the vertex. So it's x equaling to 0. And it only intersects the y-axis in one place, that is y equals 0. So in this case, the vertex, because it's on the point of origin in the middle, that is also the x-intercept. The vertex in this case, it's not always this case, is the x-intercept, and it's also the y-intercept because the vertex is on the origin. And we're going to look at examples where it's not the case. Okay, so we're looking at the values of that. And the minimum or maximum value. So if a parabola opens up, if a parabola opens up, you're looking at a minimum value. And if it opens down, you're looking at a max value, okay? So this one, it has a minimum value. It's gonna go up into infinity, right? It's gonna keep opening up, and those two sides of the parabola are gonna go up and up and up to infinity and beyond, and they're never going to stop. So there's never going to be a max point this parabola reaches. So that's why when it opens up, it has a minimum value. And that minimum value is at the vertex. All right, so the vertex is y equals 0 is the minimum value. So that is when it opens up like this. Okay, when it opens down, which is not this parabola, we'll look at some of those, it will go down. So it only ever reaches a maximum point, a maximum height. It never goes past that hump at the very top. And again, that's where the vertex is. The vertex is either going to be your minimum point or your maximum point. So that is your parabolas and your parabola terminology and shapes in a nutshell. There is example 2, 3, 4, 5, and 6. I want you to pause the video here and try to fill out as much of that information as possible, and then play the video while I go over those answers. Okay, here's example 2. Hopefully you've already gone through this. So you're gonna pick any values for x, but just pick the ones that I gave an example of. So -3, -2, -1, 0, 1, 2, and 3. Again, so you're gonna put those values, you're gonna input those values for x, and you're going to get this output. Oh my goodness, this output for y, all right? So if you haven't already done so, if you weren't quite sure where to start and you're like, oh, okay, now I know what to do, pause the video and go through. Remember, you're gonna be squaring these values of x and you're gonna be subtracting 4 from it. And you should get 5, 0, -3, -4, -3, 0, and 4. Okay, so if we have the base the most standard parabola, the basic parabola that we did in the last question, and just kind of sketched it back here. That's what those dots are for. And then we were to do the one we just did, and I'll put it in red just to color coordinate. 1, 2. And you plot those points. You would get something that, and you sketched it, you would get something that looks like this. What do you notice about that parabola? What do you notice? And hopefully your answer is, it moved down, Miss Mackenzie. Hopefully not in that kind of, with that kind of attitude, but hopefully that was what your brain was thinking. It moved down. It moved down 4 points. All right. The domain, again, unless otherwise specified, for a parabola is always x can be any real number. Always. Always. Unless it's for a very specific problem where it's for a real life problem, you can't have negative values because we're talking about like, I don't know, the production of shirts, you can't make negative shirts or something like that. It's always going to be, x can be all real numbers unless it's for a specific problem with specific additional restrictions. Okay. This time the axis of symmetry hasn't changed. So even though it moved down, the axis of symmetry is still straight down the middle. It's still, and yes, sound effects are necessary. All right, so it's still x equals 0. All right, the range this time has changed though, because the minimum is no longer at this point here. The range is now, hey, it's moved down 4 points. So the range can be, y must be larger than or equal to -4. So y must be greater than or equal to -4. Okay, other ways of stating that. Okay, again, if you do that top one, I'm super happy with that. Okay, coordinates of the vertex, that has also moved. So where your vertex for the first one was here, again, because the minimum drop, the vertex is here, and that happens when x is 0 and y is 4. Y is -4. If I said 4, oops, I meant -1. -4. All right. So pause here and try the next one. We can put in those same values that we did for x for the next one too. All right. So this is the very first one we looked at. That's a terrible sketch, but we're just going to go with it. -3, -2, 1, 0, 1, 2, 3. You should have gotten 12, 7, 4, 3, 4, and I messed something up. 7. Oops, I messed that up. I'm sorry. Okay, so okay, so 12, -2 should be 7. 7. I don't know why it's doing this. This is really annoying. I'm sorry. -2 is 7. -1 is 4, 3, 4, 7, and 12. Right? If you sketch that one, do mine in blue. You're going to get a parabola looks like this. So what you hopefully got out of it is that it moved up 3 points. The domain is always x is real numbers. The range for this one is that y has to be greater than or equal to 3. The equation for the axis of symmetry is still x equals 0, and the coordinates with the vertex have changed to x is 0, y is 3. All right, so this one, you will go through and you're going to still pick the same numbers. And when you sketch it, so you just pick -3, -2, -1, 0, 1, 2, and 3. And you get -9, -4, -1, 0, -1, -4, and -9. And you sketch it and you get the exact same thing, except for it's flipped downward. So no longer is it opening up, it's opening down. Instead of having a minimum value, that green parabola now has a maximum value. Right. So what happened? It flipped upside down. Oops, apparently upside down. And so that means it opens down instead of up. And that's my abbreviation for instead of. Okay, so data, the domain is still x can be all real numbers. The range here has changed. Instead of y having to be greater than or equal to 1, it is less than or equal to 0. I meant to say 0. So instead of y having to be greater than or equal to 0, it has to be less than or equal to 0 because it's going down. There's no values above that max point. All right, the equation for axis of symmetry is still x equaling 0, and the coordinates are still at the origin, which is 0, 0. So this one, if you tried the same numbers, you didn't get what you wanted. So you were going to have to kind of try to find where it's going to go up and come down. So you're going to end up looking at numbers like -5, -6, -5, -4, -3, -2. So it's 4, 1, 0, 1, 4. So do you see how the numbers come down and they go back up again? Okay, so that's what you want to look at. So this time, 1, 2, 3, 4, it did this. Oops, my sketching is just terrible. Okay, so instead of moving up or down, when we put a value in brackets before we squared the x, it moved. So but it didn't move to +4, and it didn't move 4 in the positive direction. It actually moved 4 in the negative direction. So even though it was a +4, we added 4 to x, it moved 4 in the negative direction. So it moved 4 points to the left, which is the negative direction. The domain, hopefully we're getting this now, is all real numbers. That double stick in the R if you want. The range, so the y is still opening up, it still has a minimum value, so y has to be greater than or equal to 0. What has changed is the axis of symmetry. So the axis of symmetry was here, but now it's here. And I don't know if you've noticed it yet, but the axis of symmetry always goes through the vertex. And the vertex, where the axis of symmetry is always x equaling something. So if the axis of symmetry always goes through the vertex, that means the axis of symmetry is always x going to be equaling whatever the x coordinate of the vertex is. So here it's x is going to equal -4 because the coordinates of the vertex are -4, 0. So hopefully we're starting to see some patterns here. The axis of symmetry is the same as this in the vertex, and the value of the range is always there. All right, let's try something else. Let's try subtracting a value from x before we move. With this one, you're also going to have to play around with the numbers because using -3 to +3 are not going to show you the curve the way you want to. You need to find the vertex. So try with 5 and then go to 9. 5, 6, 7, 8, 9. You could try any values you want, but you really want to find out where that vertex is. And we're going to show you ways to do that with technology where you don't have to do this guessing game. All right. So if this is our regular parabola, we subtract 7. We find that that the parabola, even though we subtracted 9, it doesn't go in the negative direction. It moves 7 in the positive direction. Okay, so it moved 7 points to the right, which is in the positive direction. Okay. What is the domain? You can have any value of x and you will find a value, a point on that parabola. All right, the range y is still has to be greater than or equal to 0. That is a minimum point there. That's a minimum point there. You can't go down here or down here and go left or right and find a point on that parabola. The equation for the axis of symmetry has again changed. So when you move left or right, it's the axis of symmetry that changed. When you move up or down, it's the vertex that changes. So here, it moved and it moved 7 over. So it's x equals 7. Now, without even looking at my parabola, I know the vertex is when x is 7 and y is 0, because the axis of symmetry is 7, which means the vertex has to have 7 as the x part of the coordinate, and I know the range is y has to be greater than or equal to 0, which means the vertex happens when y equals 0, because that's the minimum or the maximum point. Okay, so the last thing I want to do is talk about finding p. So we're using what's called vertex form, which is y equals ax minus p squared plus q. So this is the idea that when we added 4 to x, it didn't move in the 4 units in the positive direction, it moved 4 units in the negative direction. All right, so what I want you to think about is if you were to write this like this, well, it actually moved -4. What symbol do you have to put in front? What symbol, and I'll highlight it because you can't see me pointing, what symbol do you have to put there to make that still equal to x plus 4? And the answer is you have to put a negative, okay? Because x minus -4 becomes x plus 4, okay? So when we use what is the value of p to get a positive 4 in there, that means that p, if we're using this format, has to be -4. And why I'm pointing this out now is that it's going to help us for later when we put things in our format. So when it was x minus 7, it moved 7 to the right. It actually moved a positive 7 to the right. Square bracket. Positive 7. Oh my goodness, no, that doesn't look good. I'm going to have to fix that. I'm sorry. I've abandoned my stylist again. Not stylist. She's abandoned me. But oh no. Oh no. Let's try it right from the beginning. Right from the beginning. Y equals x something positive 7 squared. So when we had a -7 there, we actually moved into the positive 7 direction. So what symbol, I think hopefully you've already figured that out, needs to go in that middle section to make it work, to make it understand why did we move in the positive direction when it actually said -7 there, and that's because it was a negative here. Okay, so x minus +7 becomes x minus 7. So that's why the symbol is at this, the format is actually x minus p, and that's because if we put in a -7, it would become x. It would move us in the +7 direction. So what is the value of p to get -7? Well, p would have to equal a +7. Okay, if you were going to put it into that formula right here, p would have to be a positive value. So if we were given, and the reason I'm talking about that, if we were given something like y equals x minus 5 plus q, we know that it's not actually a -5, it's a +5 that is in that spot. So it's basically the opposite sign that you see. Okay. So here's the summary of our translations. We haven't done all of this stuff yet. We're going to talk, that's why this is lesson 1A, but we did play around with changing this symbol. Not the value yet, that's another lesson, but when A was positive, like the first example, it opens up. If it's negative, the parabola is going to open down. Okay, for P, it's going to make it move left or right, right? We saw that with the 4 and the 7. If it's also going to give us the x coordinate of vertex. It's also, remember the x coordinate of the vertex is also the equation for the axis of symmetry. Lots of abbreviations going on here. And if we're going to use the opposite sign. Okay, so we're just going to remember that it's actually the opposite sign. So if it says x minus 7, that means we're moving +7. It's a +7 for the x coordinate of the vertex. It's a +7 for the equation of the axis of symmetry. And we did this one actually before we did the P. The number that's in that Q position, where we square something and then we added and then we subtracted, that's what moved it up or down. This gives us the y coordinate. I'm just going to redo that. That wasn't looking good. Gives us the y coordinate of vertex. You might be saying, but we didn't have a Q in that last one. You are right. We didn't have anything here. So that means that it was technically plus or minus 0. And what was our y coordinate of our vertex? 0. And what was the min or max value? 0. It's magic. It's not actually magic, it's mathematical. All right, so it gives us the y coordinate of the vertex. It also gives us the value for the range. You have to decide whether it's greater than or less than, depending on whether it opens up or down, which is what A gives you. And we don't change the sign on that. It's just exactly what you see. So I would like you guys to try questions, all question 2 and just A for question 3 on page 157 in your textbook. Again, I've posted a link to the electronic one if you don't have access to yours. Please let me know if you have any questions. There was some new stuff in there. Stop this video, rewind, replay, try it out, make mistakes and learn from them. And if you need help, come see me during office hours and we will go through it together.